getting better in programming interviews, okay? So we'll talk about that and ways that you can avoid them, and also some personal anecdotes that I use when I was preparing for interviews to help me practice better and have my practice, help me practice better, okay? And then after that, we'll dive into some technical topics, starting with binary search, okay? And then we'll talk about some things that you might not have realized when doing programming problems that have to do with binary search, okay? So let's talk about this. Interview practice and pitfalls and how you can avoid them. Here's a little bit of background about me that may not be obvious. I was actually never really good at algorithmic interviews. Actually, in college, I don't think there was a time where I actually passed a legit algorithmic and data structure interview. And I'm not trying to gloat, but as a CS major in a top CS school, I couldn't pass any programming and data structure interview. And that's because programming is a separate skill. And we will talk about why that is. And because of this, I failed a bunch of interviews, and I actually had imposter syndrome when I came into my first internship and my first job. And you could argue that it actually impacted in how I did in my interviews, and also when I started working as an intern, because I had this imposter syndrome. And actually, the reason why I got my full-time offer at Apple was because I didn't get an algorithmic and data structure interview. I actually interned for Apple, and to pass my intern interview at Apple, I needed to be really good at front-end development. And so they asked me all front-end web development questions, and I was, I obviously knew them because I was really good at that. So I got an offer, and I decided I wanted to go full-time at Apple, and that I didn't have to interview anymore. So I kind of, in that sense, I lucked out. Because I couldn't do algorithmic and data structure interview, I didn't have to do that to get a full-time offer at Apple. I just needed to do very well in my internship, and I did that. So you could say that I actually did not get good in programming and data structure interviews until I started working full-time, and after having done a lot of research in how I should actually be preparing for these types of interviews. Yes, I am one of you. Trust me, I am not a smart person. I have just made mistakes much more than other people and have learned from them. So here's the things that you need to know about programming interviews. For the most part, it's a separate skill. I have met so many other software engineers in my life that were really great software engineers, really good at iOS, really good at front-end web dev, really good at what they did. But they were really bad at programming interviews. And why is that? And that's because programming interviews are a separate skill. Are you gonna have to reverse a linked list in your day-to-day job? No. Are you gonna have to traverse a graph? Maybe, sometimes, but for most developers, they're not gonna have to do some BFS or DFS traversal in a graph, right? And that's the main reason why people aren't good at interviews. It's because they don't do this in their day-to-day job. So now you might be asking, well, Mari, why do I need to do this if I'm not gonna do this in my day-to-day job? And my short answer is because that's the game. If you wanna win, you gotta play the game. Now, whether or not this is a fair assessment of an interviewee, that's a whole separate other question. My goal here is for you guys to get really good at these types of interviews because most companies will expect you to be good at them, okay? There's actually different types of interviews. The one I will be focusing on this for you guys will be data structures and algorithmic, your so-called software generalist type of interviews. But actually, there are many other different types of interviews, and I'll talk about that in my future lecture. There's behavioral interviews, there's role-specific interviews. You guys may have heard of this if you attended my AMA, and I will spend some time talking about those interviews and how you should prepare for those as well. And the thing about data structure and algorithm interviews is that they have a steep learning curve. But once you crack it, you're actually going to be able to ace a good amount of interviews because a lot of these companies are very similar in algorithmic and data structure interviews and the questions that they ask in those types of interviews. So you guys may have heard some, I don't know, YouTube influencer saying, oh, I got 10 other offers and from these tech companies. And it might sound impressive, But actually, once you are able to crack one interview at a reputable company, chances are you can crack other interview loops for other similar companies as well. So here's the thing. There's a high amount of investment needed to get good at programming interviews. But once you get to that level where you're consistently doing well at them, there's going to be you're going to have a lot of options in your career, which is great. Because a lot of these programming interviews are very similar. And once you get good at them, it will stick with you. And you can apply that to pretty much any place that you apply for. Andrew is asking, tech lead? Yeah. Yes, tech lead, yes. I'm not a fan of the guy. Apparently he was my coworker. Actually, I saw him in my building walking around. He looked familiar. Now, I'm not gonna, his personality aside, yes, kind of like tech lead. I guess, he's obviously knows a thing or two about programming interviews. But I'm not gonna talk anymore about him. I have some opinions about his personality, but yes, okay. Tech bait, yes. Web Dave, yes. Tech bait. I love his titles for his YouTube videos. It's very clickbaity. Gotta get that ad money, All right. Anyways, enough about tech lead. Let's go ahead and move on. Actually, before I move on, do you have any questions about what I just talked about? As a millionaire. Yeah. Okay, cool. Let's go ahead and move on. So here's the first thing. I want you guys to realize how you practice matters. How you practice has a huge impact on your performance in these types of interviews. But the thing is, very few people are willing to practice effectively for interviews. Here's a quote by Bobby Knight. He's a famous basketball coach. He says, "Most people have the will to win. Few have the will to prepare to win." And that's just so true with programming interviews and tech interviews in general, is most people want to get a job at company X, company Y, but most of them are not willing to do what it takes to practice effectively so that they can ace their interviews. So realize that how you practice matters, and that whenever you guys are practicing, make sure that you're asking yourself, is this the best way to prepare for this type of interview? Jordan has a question. Is it true that front-end interviews, you don't get asked data structure and algorithm questions for interviews? I didn't. Are data structure and algorithm questions more role specific? Jordan, I guess I will caveat these types of questions with the fact that every company is different and everyone has their own interview practice. I can only speak for my experience and the majority of what companies do. But in the majority of what companies do is that they will ask, for example, if the role that you're applying for is a front-end web dev. If you're applying for, I guess, let's just say for Facebook, you're expected to know front-end web dev skills, role-specific things that you will do in your day-to-day, but you're also expected to know how your software generalist skills, which are your algorithmic and data structure skills. So for a good part, for a lot of the companies that you're applying for, you're actually going to need to know both, right? So in some companies, they might just care about your front end and JavaScript skills. So the main lesson here is, depending on what companies that you are applying for, you need to tailor your practice to those types of interviews. So for example, if you're applying to all companies who only really care about your front end web dev skills, then yeah, why do you need to practice your software and algorithmic skills? You only need to practice your front-end web dev skills. But if you're looking to apply for FANG companies that are notorious for having really hard software generalist, algorithmic, and data structure interviews, then you should probably spend more time preparing for those types of interviews. Okay, so TLDR, it really depends on the company that you're interviewing for. Make sure you do your research. For a lot of companies, they expect you to know your role-specific skills, but also have software generalist skills as well. For a few companies, all they care about are your role-specific skills, the platform that you're applying for. Okay. Any more questions before I move on? Okay, cool. So let's talk about this. What do you guys think are the most common mistakes when practicing for interviews? Why don't you guys jot that down in the lecture thread? I want to see what you guys are thinking right now. Picking your nose, yes. Probably a common problem. What else? Not enough leak code, vague practice, not understanding the question before answering, tutorial hell, no unique portfolio projects to explain, communicating too much or too little, mechanical responses, and not painting a picture. Okay. Not practicing under time constraints, stumbling over your words, using filler words, not taking notes on what you will need to come back and review. Oh, okay. These are some insightful comments. Let me show you guys what I came up with. And I actually think what you guys have stated are very valid reasons. But here are the things that I will talk about today. And here are the things that I found to be the most common among people, and also for myself as well. So, one common mistake that I see is mindlessly doing as many problems as you can. In college, 90%, or pretty much all my friends, when they got an interview, let's say at some company, they say, oh shit, I have an interview with this company in 2 weeks. I'm gonna go on LeetCode and go through the most popular questions and do as much as I can. Nope. Wrong approach. That's not the best and most effective way to practice for interviews. And obviously, you shouldn't be practicing 2 weeks before your interviews. You should be practicing at least, I would give yourself at least a couple of months to do some solid amount of preparation for these types of interviews. Second mistake that I see, forgetting about problems and patterns you've already seen. So if you are going through your practice and you're routinely practicing for these types of interviews, you will have done a good amount of problems by the time you are prepared. Now, the thing is, most people forget the problems and patterns they've already seen. So when it comes to the interview, they can't recall it, and they might have as well not done those problems anyways because they can't even recall it, right? So that's another problem that I see most people make. Another mistake that I see is not being emotionally prepared. Obviously doing LeetCode on your couch is very different from a stranger judging you while you're coding. So most people don't realize that until they're actually in the interview and they start sweating bullets and they don't do well and they fail. Next thing is getting demotivated. I have seen so many people get so excited when they get a chance to interview, but after a few days of preparing, they get demotivated. And that's because the problems they're doing are not the caliber they're currently at. So they get demotivated, they can't solve all these LeetCode hard questions, and they just quit. And that ultimately dooms them to fail the interview because they've stopped practicing. Another thing is not preparing for other types of interviews. So again, you guys, programming and data structure interviews are a specific type of interview, but there's also other types of interviews. There's role-specific interviews, just like what Jordan mentioned, where they ask you about JavaScript, React, and whatever. There's behavioral interviews, which you will be talking about with your TL. Those are also important. There's screening interviews that you have with the recruiter in the beginning. And also there's another type of interview called system design, which are mainly for more experienced hires. You probably won't encounter that, but we'll talk about it in a future lecture. And it's so funny because I was actually on newsfeed and Facebook and I see this ad. I thought it was very funny and it's very relevant to the lecture that I'm giving, so I decided to put it here. I wouldn't say that I completely agree with this ad. They say, did you know that the best interviewees don't grind LeetCode? They don't solve 500 practice problems or do a 45 mock interviews or do whatever. So I don't, obviously this ad is very clickbaity, but if you want to get really good at programming interviews, you probably don't need to do as many as 500, but you know, in my experience, I've had to do hundreds of these of leak code questions before I got really good at them. So I don't think this ad is fully accurate. I think it's more clickbaity. But I just thought that this was funny, so I decided to post it here. Let's see. Let me see some comments. Do companies use LeetCode, HackerRank, and Edibit? They don't. I'm not sure what you mean by use LeetCode or HackerRank. I know for actually some companies like to use HackerRanks for online assessments. I don't know what Edibit is. I have not heard of that. LeetCode, I don't think companies specifically tell you to solve a LeetCode problem. They mainly use HackerRank. Yeah. Okay, cool. Let's move on. Let's talk about the first problem, which is mindlessly doing as many problems as you can. So I want you guys to remember this. The amount of LeetCode questions you've done does not equal to the amount of your understanding of the material. Let me say that again. The amount of LeetCode questions you've grinded does not equal to the amount of your understanding of the material. You could do all the LeetCode questions out there, but if you don't get the patterns in those problems that you've done, it won't do you any good. You still won't do well in programming interviews. So realize that brute memorizing solutions is not efficient, right? Do not go in LeetCode and do random problems and memorize the solutions, because that will not help you. You will just forget them, and chances are that question probably won't even be asked, okay? So here's one thing I would do to avoid this mistake. Consider adding deliberate practice to your regimen. Deliberate practice is a special type of practice that is purposeful and systematic. So for example, if you look here, here's a chart of just normal practice. And over time, your skill plateaus. But with deliberate practice, what you do is whenever you feel like you're plateauing, you shift things, you shake things up to shock your brain so that you can learn new patterns and level up your game, so that over time, you're actually able to reach higher levels in your skill without plateauing. So how does this, how does deliberate practice, how do you incorporate deliberate practice into practicing for programming interviews? So instead of doing mindlessly doing problems on LeetCode and doing random questions on LeetCode, do deliberate practice by doing 20 questions or more per topic. So for example, it's much more effective for you to do 20 problems on linked lists versus doing 20 random problems on LeetCode. Why is that? Because if you do enough problems on linked lists, you will see the patterns that you use to solve linked list problems. And actually, once you do enough, things start to sound similar. The patterns and the techniques that you use in this one problem can be applied to this problem that you have, right? So once you do enough problems on a single topic, you would have learned all the ways or most of the ways to solve problems of that type, okay? So what I did when I started practicing was I would do 20 linked list questions. Then I would do 20 graph questions. Then I would do 20 array questions. And I would do that for all the topics that are commonly asked in interviews, okay? Any questions about deliberate practice? Let's see. Jordan asking, why do companies love HackerRank if it's hard to understand comparing to other platforms? I don't know, man. You ask them, I don't know. Daniel asking, how do you structure your deliberate practice? I just answered that. How much time do you recommend to spend in one topic? Pedro, it really depends. Some topics for certain people are much easier. So for example, I found binary trees to be easier than, I don't know, than linked lists. So I spent less time on binary trees. It really depends on what topics you're comfortable with. Again, when I say 20 problems, it can vary per person. Like if you feel comfortable after 10, 15 problems, then feel free to go ahead to the next topic. If you still don't feel comfortable after 20 problems, do more. Again, everyone is different, right? If you need to do more practice, then do more. If you can get away with doing less, then do less. It's very individual. It's very personalized. Your practice should be very personalized to you. Would you suggest taking notes by hand while practicing in order to better remember the methodology of the topic like linked list, or would that be a waste? Oh, I see. Yeah, Daniel, I think you touched on a important thing is to remember the patterns when solving problems. And I will talk about how I did what I did that. Taking notes can be a great way, and looking back at that notes after an extended period of time is a great way. But I have a process, or I have a method that I use when preparing that I found what was really nice, and I'll talk about that in a bit. Okay. And actually, it's that topic now. So the second one, or the next problem, is forgetting about problems and patterns you've already seen. So acing interviews is largely on you recognizing a pattern and solution you've previously done or used and applying it to the problem that you're given. So because of that, fast recall is very important during interviews. If you can't recall what you've done in the past, then you probably might have as well not done it at all, right? If you can't remember the problems you've done in your interview, then you might as well not done any problems, right? Because you forgot them, okay? So that's the main thing that I see most people make, is that they do all these problems, but when it comes to the interview, they can't remember them. So how do you avoid this pitfall? To avoid that, what I use is something called spaced repetition. Spaced repetition is simple. All it means is to review something more than once. So if you look at the chart on the graph, you can see that the y-axis is retention, how much information you're retaining. Obviously, in the beginning, after you initially studied it, you've retained most of the information. But what you can see is after a while, your retention really drops down at a steep cliff. So after a day, research has shown that you remember 40% of what you just did a day before, right? So what spaced repetition does is when you're about to forget something, you review it. So after a day, after you initially studied, after a day, you review it again. So you have 100% retention again. And what you can see is that this slope is less steep than the initial one. And what this suggests over time is as you do spaced repetition, after enough reviews, it's going to take a very long time for you to forget that thing. And actually, if you've done enough reviews, you're not going to forget it all, right? So in my practice, when I practice for interviews, I use spaced repetition, and every problem that I did, I made a flashcard using an app, which I will show you later, called Anki. And Anki has a spaced repetition algorithm built in. It's simply a flashcard app where the flashcards that it shows you are the things that you're more likely to forget, right? So it'll prioritize cards that you're about to forget, and it'll show it to you. And depending on how easy or hard you find that card, it will show it to you sooner or later, okay? So every problem that I did, I would make a flashcard where the front part was the problem statement, and the back card was the code that I wrote. I'm not copying code from anyone. This is the code that I wrote to solve that problem. And so that what I would do is I would get that flashcard every Monday, every morning, and every night I would review that flashcard, those flashcards. And I would look at the problem statement at the front of the card, and I would try to remember the solution to that problem. And then I would tap it, and it would show me the solution. I would see whether or not I got it right, or whether or not I was on the right path. And depending on how hard that I found it, I would mark on Anki whether or not I should review it sooner, or I really remember this, I don't need to review it as much. So let me show you guys what that actually looks like. I'm not saying that you guys need to use Anki, but Anki is a good way to use spaced repetition, to add spaced repetition to your practice regimen. You can use whatever you find fit. Again, I'm you can use, there's a lot of tools to accomplish spaced repetition. I'm just showing you how I did it, and you guys can emulate it, or you guys can find another way that works for you, okay? So here's Anki, simple app. You can see that I have a bunch of decks that is showing you guys, oh, I try to apply spaced repetition to a lot of things. I applied it for programming interviews. I applied it to the books that I've read. I've applied it to the CS concepts that I've learned. I even apply it to my work at Facebook. I apply it if I want to learn geography around the world, GRE vocab, learning programming languages, iOS interviews. So there's a lot of applications that you can use for Anki. Programming interviews is just one of them. So I have this deck. Again, this deck is specifically for programming interviews. The front of this is the card. This is the front of the card. This is a problem from LeetCode that I solved. It says paint fence. And here's the problem statement. There is a fence with end posts, blah, 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 blah. And then when practicing, I would try to remember what the solution is, the algorithmic solution to this problem. And once I know what it is, I simply tap it, and then it will show me what the code that I wrote was. And again, I didn't copy anyone's code. This is the code that I wrote. And you guys shouldn't be copying anyone's code. This should be the code that you wrote, because you're more likely to retain it if you're the one who wrote it. Okay, don't be copying someone else's code that you don't even understand. That's not a way to practice. But again, this is the solution that I wrote, and I asked myself, okay, am I able to remember this if I get asked this in an interview? I asked myself that. Or was I able to get the algorithm? If so, then I just tap good, and you can see that, you know, if I tap good, it will show this card to me again 2.4 years later. So again, I've reviewed this deck so many times that I would probably not forget this in 2.5 years, okay? But you can see, if I tap that, then it says I finished the deck for now. But anyways, you can see how I use this app, or how I use spaced repetition so that I don't forget the problems and patterns I've done in the past. Does anyone have any questions about how I use spaced repetition so that I'm able to recall all the problems that I've done? And for context, I've done 300 plus problems, and I remember a lot of them. So using this technique, I am able to retain large amounts of information that I've done in the past, and I'm able to recall that during an actual interview because of spaced repetition. Any questions? Okay, let's move on. Next thing, not being emotionally prepared. So the emotional and physical, before COVID, environment during interviews are different. Again, doing problems on your couch or in your bed in LeetCode is very different than a person staring at you or judging you while you're doing a LeetCode problem. And to avoid this, I encourage you guys to simulate conditions similar to an actual interview. A few guys mentioned that you guys should time limit. A common mistake is you don't time limit yourself when you're practicing. I would also suggest not to use compilers. Don't use autocomplete. Don't rely on those crutches in an actual interview, right? When you're coding your solution, first do it in a text pad that has no autocomplete, no compiler checks or whatever, to make sure that you really know the language, right? To get really good at interviews, you can't have the programming language be a barrier to acing, to writing code. For example, JavaScript should be second nature to you if you're a front-end web developer. Swift should be second nature to you if you're iOS. If it's not, then you haven't practiced enough. That's my rule of thumb. If you have to think about how to iterate a while loop, or how to traverse a binary tree, or how to define a class in your programming language, you haven't practiced enough, right? So make sure you are simulating the actual conditions in an interview. I love a quote by Mike Tyson. Everyone has a plan until they get punched in the mouth. And that is so true with interviews. People think they're ready until when they hop on that VC, they start sweating bullets. All their skill goes out the window because they haven't practiced for that moment. So make sure that the environment you're practicing in is very similar to the environment that you will be in. I recommend doing mock interviews, whether it's with strangers or with your friends. I recommend doing it with strangers because that is more like what an actual interview is, okay? Next thing is getting demotivated. So imagine me in college realizing that I have an interview at Google. I hop on LeetCode. Since Google was a very lucrative company, I know that they're going to ask me hard questions. So what I did was I went on LeetCode, tried to do LeetCode hard questions, can't solve them, get demotivated, stop practicing. That ultimately dooms me to fail the interview. That's a very common thing that I see in a lot of people, is that they think they can start doing LeetCode hards in the beginning. But actually, those problems are really actually freaking hard. And actually, a lot of problems that you will see in programming interviews are actually more to the medium level. So just remember, you want to be motivated when you're walking in an interview. You don't want to be hopping on VC nervous because you couldn't solve the last 10 LeetCode questions you've done. You want to come in there confident, right? You want to have a good mental state when you're in that interview. Doing all hard problems and not being able to solve them is not a good, it's not a good way to get in that environment. Okay. Sorry, VC, I meant virtual conference like Zoom. So what I did so that I don't get demotivated is I interleaved easy, medium, and hard problems together to gain confidence, but also simultaneously challenge myself. Okay. So in the beginning, for example, when I'm just learning about linked lists, it doesn't make sense for me to do a linked list hard question. I would start off with doing some easy. And when I realize I'm getting really good at those easy problems, I would sprinkle in some mediums. And it will get to a point where I'm just starting to consistently solve medium problems. And then that's when I start sprinkling hard problems, right? The hard problems are hard. That's why they categorize that. I don't fully expect myself to solve all the hard questions, but they're mainly as a way for me to push me to get better and go up to the next level in that topic. Here's a quote. It's by it's from a book that I read. It's called The Art of Learning. It's about a person who was a world-class chess champion, but also became a world-class martial artist. He says, "A competitor needs to be process-oriented, always looking for stronger opponents to spur growth. But it's also important to keep on winning enough to maintain confidence." And that's key, you guys. You guys want to walk in that interview being confident that you can work with the interviewer to solve the problem. You don't want to walk in there nervous as heck, okay? I get questions from students that I've taught. They say, "Mari, I'm still stuck at a problem even after looking at the solution. What do I do?" If you're stuck in a problem, and then you've looked at the solution, you still don't get it, take a break, take a walk, then look at it again. Code it up yourself, and then rinse and repeat. And also what I like to do is in LeetCode, you can see other people's solutions in the submissions, tab. If you don't get someone else's solution, look at someone else's solution, see how they did it. There's many ways to do a problem, and some of them may make sense to you, some of them may not. So just make sure that you rinse and repeat until you understand the solution to a problem, is my advice. David's asking, there are a lot of flashcard apps with Anki in the name. What is the full name of the app that you use? I will link Anki after this lecture so that you guys can have a link to that, okay? Any questions about motivation when it comes to practicing for interviews? Cool. All right, so that's actually all I have to say about common practice mistakes and how to avoid them. Do I have any questions before I move on and dive into binary search? All right, cool. No questions, let's move on. So you guys have heard of binary search, right? Please nod or shake. Good, she nods. All right, so hopefully this will be a review. So the main concept of binary search is that you have the search space on each iteration for sorted collections. So let me just get my annotations. So for example, if we get this array over here and we're searching for 8, for binary search, what we'll do is we'll look at the midpoint and we'll say, oh, the midpoint is 2. Is the thing that we're trying to search for on the right side or on the left side? Since the thing that we're searching for is 8, and since this is a sorted array, we know that 8 will be on the right side. It will be on this side. So on the next iteration of binary search, we have the search space. Now our min is now at 4. We move it from -3 to 4. Now max stays the same, and we keep doing this again until we find the thing that we are searching for, or if we don't find it, then we didn't find it. And because we are doing this halving on each iteration of binary search, we get O of log n performance. Okay? Any questions about binary search, the steps for binary search? They should be reviewed. So here are the things that I want you guys to know about binary search. Binary search is very useful for sorted collections. Arrays, strings are also collections, tuples are also collections in Python. But the thing most people don't realize is binary search also works for ranges. And we'll talk about an example of ranges. And also binary search can be implemented iteratively or recursively. Now you might be asking, Mari, which one should I do? You should be very familiar. You should be really good at one method, but also be familiar with how to do it in the other method, okay? Because some problems are better solved iteratively or recursively, and vice versa, okay? And now you might be asking, Mari, how do I know to use binary search in the problem that I'm given? Well, here are some certain keywords that I like to look out for. And what you guys will actually learn is how the problem is phrased actually has clues in how you can get the optimal solution. If you have anything that says sorted or ranges, you should be thinking immediately binary search, okay? And the thing I want you guys to realize about binary search is that coding it up should be muscle memory. If it's not muscle memory, then you haven't practiced enough. Binary search is so common that this should be muscle memory to code up, okay? So here's an example. Square root. We want to implement this function, square root, that takes in x, and it spits out an integer. So for example, square root 16 is 4. It's a perfect square. Square root 8 is actually 2.82842, but we'll truncate that. So we'll just print out 2. This, you might be wondering what language this is in. This is actually in Swift. Because I used to do my programming interviews in Swift. So this was before I learned Python to teach you guys. So this is in Swift. And we'll assume that x is greater than 0. And since the return type is an integer, we will truncate the decimal portion of the square root, and we will just spit out the integer portion. Any questions about this function that we're about this problem before we move on? Okay, so let's talk about this. What do you guys think is the brute force approach to get the square root of a number? I'll give you guys 1 minute to think about it. If you think about it, post it in the chat. Name a brute force solution. Try every float. Yeah, so we can try every number, right? We can try every number before the number that we're searching for and see if that is the square root. Okay, that's one. Yep. Yep, John says square number starting at 1, increasing it until it reaches that number. Yes, exactly. So you guys have the right idea. So we can try every value from 0 to the target until we find the square root. You can probably get away with doing nothing more than half the target, but that will still have the same linear performance. Okay? So that's brute force. Can we do better? We can do better. That's my... How can we use binary search to solve this problem? Give you guys another minute. So remember, binary search can also work for ranges of numbers. How can we use binary search to find the square root of a number? I see Daniel has an idea. Half the number. If it's too high, go left. Too low, go right. Okay, yeah. That sounds like a reasonable approach. So yeah, we can use binary search to keep having the search space. In the beginning, our search space is, for example, if we're trying to find the square root of 16, our search space is anywhere from 0 to 16. So now that we have a range, we know that we can use binary search to keep having our search space. In the beginning, what we will do is we will find the midpoint here. Our current search space is anywhere from 0 to 16. So our midpoint is 8, right? 8 squared is 64. So we know that the answer is somewhere in the left part of this range, which is anywhere from 0 to 7. So what we'll do is we'll do the same thing. And we'll keep having the search space until we find the square root. Okay? So the key thing here is that square root doesn't just work for arrays and strings, it also works for ranges. And that's because ranges are inherently sorted. Okay? Any questions about how we will use binary search to get the square root of a number? Okay, cool. Sounds like there's no questions. So let's go through the LeetCode link. Here's the LeetCode version of this problem that we talked about. And basically, we'll ignore this because I want us to practice OOPR because again, OOPR is very important when solving these types of problems. First one is understand. Understand is where we come up with a suite of test cases so that we can better understand the problem and that we know its behavior. In this case, I'll just do 3 test cases. For example, if our thing is, if x is 16, then obviously our output should be 4. If our input is 8, our answer should be 2. Because remember, we're truncating the decimal portion. It's actually 2.82 blah, 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 blah. But it's asking us to spit out an int, so we are spitting out just 2. Also, we should probably check out the edge case. If it's 1, then we should output 1. Okay? In this case, we'll assume that the values that we are given are larger than 0. So that's our understand portion. You guys should already know what each step is. I hopefully should have hammered that to you guys in the beginning. The next step is plan, right? So our plan is to use binary search. So use binary search to keep having the search space. And we also want to keep track of the nearest solution that we found, right? We want to keep track of the nearest solution that we found, and we output that solution in the end. Next one's execute. That's simply us writing down the code. So let's go ahead and do that. We are a little bit short on time, so I'm gonna go through this a bit faster. But we will have our 2 pointers, min and max. Our min would be 0 in the beginning. Our max would be the number that we are searching for. Again, this is our search space, anywhere from 0 to x. We're going to use another variable called res to keep track of the closest solution we found so far. Just like binary search algorithms, we will have something that is while min is less than or equal to max. What's the next part? What is mid? Let me ask you guys this. What is the mid value? Because remember, we're always in binary search, we're getting the mid value, the middle value in the current search space. So what is mid? Yes, good. X divided by 2. In this case, we want to cast this to an int first, and then we'll do min plus max over 2. Okay, this will be our mid value of our current search space. So now that we have our mid value, we need to know the squared, what is the squared value of that? So squared equals mid times mid. Now here's the meat of binary search. If squared is equal to x, then we've simply found the solution. We simply return the mid value. Actually, I don't think I need int mid. I just return mid. Else, if the squared value is greater than the value that we are looking for, we know we need to go to the left. So that is simply max equals mid minus 1. Okay. Else, if the squared value is less than the number we're searching for, then we need to go to the right. So we do min equals mid plus 1. Sorry, min equals mid plus 1. Also, we also need to keep track of the closest value we found so far. So for example, so we need to update res. So you guys might be asking, Mario, why do we need to update res? Well, for example, if here's our search space, let's say this is x is the mid value. Sorry, now let me. If the number that we're searching for, x, is here, and let's just say that this is y, right? If y squared is less than x, right? Then we know we need to go to the right. But we don't know if the answer is y dot is between the answer, the real answer could be y to y dot 99999, right? So even if we go to the right, y could still be the answer because we're truncating the decimal portion, right? The actual solution could be anywhere from y up to y dot 99999, okay? Which is why we're updating res equals mid. Okay, because that could actually be the answer. It's just that we don't know because we are truncating the decimal portion, right? Anyone have any questions on this, on why we're keeping track of res? It's mainly because of the decimal portion, because we're truncating the decimal portion. Okay, cool. So now that after we've done our binary search, we simply return res. Okay, and I should probably just cast this to an int. Any questions about this? So you can see how we are using binary search to solve this problem. And unlike the problems that you're used to using binary search where you're iterating over an array or a string, we are using ranges. And that's one of the key things, the key patterns when you're dealing with problems that have to do with binary search. It's not just about sorted arrays. Ranges can also be used, binary search can also be used in ranges. So let me just run this out real quick. Let me go through the next step, which is R, which is review. So let's review our code. We start with min, which is 0. Max is the x, the value we're searching for. Res starts at 0. While min is less than or equals to max, we find a midpoint value. We squared it, and we check if it's the value that we're looking for. If so, we return mid. If the value that we're looking for is greater than x, then we go to the left. If it's less than x, we keep track of that value because that could actually be the result, and we go to the right. Any questions about this? If I run the code, let's see what I get. Cool, looks like it's right. If I look here, cool, looks like it's accepted. Yeah, so it looks like we have the right answer. Let me go back to the slides. Before I go back to the slides, does anyone have any questions about binary search? Hold on 1 second, you guys. I have a call I need to take. Yes, sorry about that, you guys. I just ordered DoorDash and my food is here. Sorry, bad timing. But yeah, Rabba is asking, could you share the link of the LeetCode problem? Yes, you guys will have access to my slides, which has the link to this problem. Again, as always, I will post all the code that we write in a hack empty afterwards, okay? Cool. Let's go ahead and move on. So yeah, that was actually it. That was a binary search demo. Does anyone have any questions about binary search? Again, I want to stress this slide because we're not listening. Here's the things: keywords, sorted, and ranges. If you see this in the problem statement that's given to you, immediately think binary search. And actually, why don't we do this as an exercise? Why don't you guys tell me some things that you guys can use binary search on. So here are some ideas. You can use binary search on Git history, right? The Git history is inherently sorted, right? Each hash in your repo has, I don't know, A, B, C, D, E, F, G, H. Imagine these are the hashes for your commits. These are actually sorted by time. And since this is sorted by time, you can do a binary search. For example, if you want to find which diff broke your code, you guys can probably do a binary search on your Git history to see the diff, the first diff that caused the breakage. Okay. Do you guys have any other ideas of what things you can use binary search on? What other things can you guys use binary search on? Thank you, Jordan. Deliver your food, do DoorDash. Anyone have any ideas? Really? Search bar when filtering by ID. Raul, can you explain a little bit more how that will work? Anything that's sorted where you have to guess. Yeah, so how about How about dates? How about a time range, you guys? What if you have to search anywhere from Jan 1, 2020 to December, I don't know, 30, 2020? Can you do binary search between these date ranges? You can, right? Dates are inherently sorted. YouTube history. Interesting. Yeah. Imagine you have like your history. If you have video 1 up to video N, let's say video N is the most recent video you've watched, and you're trying to see if this person has watched video X. Actually, if maybe not that kind of query, but if you have a sorted array of videos, some type of searches might be more efficient because this is sorted. Searching for a specific video, I don't think will work because you have to search the entirety of the array. But depending on the problem that you want to solve with your history, it might be possible to do binary search. Let's see. Binary tree, if it's balanced. Interesting. Well, let's say that I have actually, we'll talk about binary trees and binary search trees. And there's actually a neat trick that you can do to do binary search based on the values you get from a binary search tree. So we'll talk about that in a future lecture. But yeah, you can use binary search even with trees. Pretty cool. All right, cool. So sounds like you guys are getting an idea of when to use binary search. I will post these slides and the HackMD and the LeetCode problem that we've solved. And yeah, that's all I had. Remember, our lecture starting from now will start at 6 p.m. For this sprint, okay? So except for this lecture, we start at 6:30 because we didn't really tell you guys that we're gonna start earlier. So starting the next lecture, we'll start at 6 p.m., okay? And my lectures will be an hour long and we might have guest lecturers on some days, okay? All right, any last questions before we end lecture? All right, cool. Well, you guys have a good night. I'm gonna go ahead and get my DoorDash. I am hungry. So you guys have a good evening and have fun talking about behavioral questions with your TLs, okay? All right, see you guys.